So this video will discuss the mole to number of particles conversion. So this mole to number of particles conversion is very much related to the concept that we learned about Avogadro's number and the concept of the mole previously. Remember that a 1 mole of any substance is equivalent to the Avogadro's number. And the Avogadro's number is equivalent to 6.02 times 10 to the power of a positive 23 exponent. This number here gives us the number of particles in a mole, in 1 mole of any given substance. So the 6.02 times 10 to the 23 is a fixed value of a mole. And the other name for this value is the Avogadro's number. So for today, we're going to get the number of particles with a given mole in a certain problem. So there are only 2 steps that we need to remember. The first step is we will identify what's our given mole from the problem. And then after that, the given mole will be multiplied to the Avogadro's number value. And that is the direct step to get the number of particles. Write the given mole and then multiply after. When you multiply and then you input in the calculator, your final unit of the answer can be in any of these 3 units. It can be atoms, molecules, or formula units. So we have 3 options for the final unit. The problem will ask you the final unit, or will tell you what should be the final unit. To help us recall what are these things, so when we talk about atoms, we're talking about one specific element that you're going to find out in the problem. So if it's one specific element, the final unit will be atoms. If it's a covalent compound, in which it consists of non-metal elements, then the unit for that will be molecules. So if your compound is covalent in nature because it's all non-metals, then the appropriate unit for that is molecules. And lastly, if we're dealing with ionic compounds in which it's composed of metals and non-metals, or our cations and anions, then the appropriate unit for that will be formula units. So formula units is a very specific title that we give for ionic compounds. Okay? Molecules is exclusive for covalent compounds. Okay, now let me give you sample problems right now in order to illustrate these 2 steps. Okay, let's go to our first problem here. Let me zoom it out. So the first problem says, how many formula units are there in 2.07 moles of Ca3PO42? Now, do not get intimidated by the chemical formula that you are given. It's all right because this is really the chemical formula of your substance. So it's all right to have lengthy chemical formulas, but it shouldn't complicate the steps. The steps will remain the same. I just want you to be accurate in reading and writing the substance, okay? Because that's part of the labeling. So it's asking for the formula units from the given 2.07 moles. And so the first step that we know of is you have to list down or write down the given mole. So we write down 2.07 moles of, we don't have to put the substance this time because it's just a solution. So we're just going to write the number and the unit moles. After that, we're going to do dimensional analysis to make sure that our units are correct. Now, in dimensional analysis, we have this style. We put a multiplication sign, and then we put the line that will separate the numerator from the denominator. And it says in our step that we have to multiply it to our 6.02. So when we multiply something, we should put the 6.02 on top, right? So that will be on top. So that's 6.02 times 10 to the power of positive 23. And this one is our Avogadro's number. And our Avogadro's number is always equivalent to our 1 mole. That's what we know. Mole is shortcut as MOL. You don't have to spell the correct mole word, but the shortcut or the abbreviation of mole is just removing the letter E, and that is accepted. So 1 mole is always equivalent to 6.02 times 10 to the 23. And what should we put as a unit for the Avogadro's number? Now we're going to use whatever it is that is being asked in the problem. Formula units is part of the particles, and it's very specific. So we're going to use that as our unit for Ca3PO42. So that's 6.02 times 10 to the 23 formula units. And that's equivalent to 1 mole. So what we're doing here, let me box this to emphasize. This one serves as this will serve as our conversion factor. A conversion factor is an equivalent of 1 mole. So 1 mole is always having this particular value, and we said it's a fixed value. So this serves as our conversion factor to be able to answer how many particles are there in this given mole that we are given in this problem. So once we use a conversion factor, we know that the mole is down in the denominator and the mole here is on top from the given, because the given is always assumed to be on top, right? This is assumed to be over 1. So the mole here and the mole down here will be cancelled out. So we don't need the mole. That's why we cancel it out from the conversion factor. And we're going to need whatever is left there, which is the formula unit. And now that we have canceled our mole, we can now directly use the calculator so that we will get the final answer. So in our calculator, I'll put that aside. We will now input 2.07. So we'll input 2.07. And then we press multiply, so multiply times, and then our exponent now, the way we practiced a while ago. So we will input, it's better to put a parenthesis to enclose it, and then put your 6.02, and then the times 10 to the power of n here, and then input the exponent 23, and then we can, to close the arrow, to close the parenthesis, we can press the arrow to the right to close the parenthesis like that. And then press enter. And then you will see a lot of answers there with the times 10 to the power of 24. How many should we get? If we have 3 significant figures in the given, we're going to get the first 3 numbers in the screen. So what we see in the screen is the first number is 1. And then dot, we're going to have 2 more numbers, so that's 2, and the 4 has to be rounded up to a 5 because the number that we don't need, the first number that we don't need is a 6, and we know that we need to round up if it's 5 up. So the 4 becomes a 5 this time, so that's going to be 1.25, and then we copy everything, the scientific notation, that's times 10 to the power of 24. So that's the entire answer, numerical answer for this problem. And then, whatever is the unit that's not cancelled, or actually the unit that's being asked in the problem, that is the unit of our answer. So that's 1.25 times 10 to the 24 formula units of, so we're now going to specify the entire substance, chemical formula that is asked in the problem. That is Ca3. All we need to do is just copy that, PO42. And so we now get the final answer for this problem. The whole answer should be the number, the unit, and the substance. 3 things. So in number 2, we have now determine the number of molecules. So this time, molecules is the specific particle that we're looking for. So number of molecules in 0.5 0.55 mole of H2SO4. So our substance is H2SO4. We're going to get molecules for this because all of the elements here are non-metals. So that's why it's molecules. So again, the first step is we write the given mole, the number, and the mole unit. So that's our given. Next, again, we multiply it with the Avogadro's number. So Avogadro's number will be 6.02 times 10 to the 23. And because molecules is the one being used, so we will use molecules in here. And then, of course, the conversion is always that this number is equivalent to 1 mole. So the whole thing here, I'm going to put a parenthesis here so that we don't get confused with the 2 multiplication, to emphasize that the one inside is our conversion factor. And now, we know that this given 0.55 mole is over 1. Let's assume it's always over 1. So this is on top all the time. The given is on top. So the mole there on top and the mole below will cancel out so that we will get the correct unit afterwards. After canceling, we're now going to multiply it in our calculator. So let's put that aside and let's input this in our calculator. Okay? Let's be ready now. So let's input 0.55. 0.55 times, you can enclose it in parentheses to be safe with this. So times, open parenthesis, 6.02 times 10 to the 23. And then I press the arrow to the right to close the parenthesis to make sure that the whole quantity is isolated when it's calculating. Then press enter, and then you will see 3.311 times 10 to the 23. That's the whole thing you should see on your screen. Now, how many should we pick? Let's look at our given. 0.55. How many significant figures is this? This is 2 significant figures. Only the 5 and the 5 are significant here. The 0 is not included. So we're going to pick first 2 numbers because our basis will be the given 2 significant figures. So we're going to pick the first 2 numbers. So that's going to be 3.3 only. No need to round up because it's a 1 after the 3. So basically, the answers for this will be 3.3, and then you put the exponent times 10 to the power of 23, and then all you need to do is copy the molecules there, molecules, and then you put of the substance H2SO4. H2SO4. And so, this is our final answer for this number. We have the value, the unit, and the substance. So, solve for the number of oxygen atoms in 4.67 moles of NaClO4. Now, be watchful for this kind of problems because you're asked for the number of oxygen atoms only. Oxygen atoms only in 4.67 moles of NaClO4. NaClO4 is not just oxygen. It contains 4 oxygen, but the whole compound itself is not oxygen. So there is an extension that we're going to do in this particular problem. The steps will still be the same. Let's find first how many particles of NaClO4 as a whole are there. So we will still begin with writing our given 4.67 moles Na. Let's put that there because this is going to be very crucial. NaClO4, and then after that we're going to multiply this to our Avogadro's number again. So 6.02 times 10 to the 23. 1 mole of NaClO4. And this is NaClO4 formula units. Okay, formula units is, I'm just going to shortcut it as F.U. Formula units because this is an ionic compound. So formula unit, just think about it as a compound, the whole molecule, the whole compound itself, NaClO4. And then, because this is still NaClO4, we need to get oxygen atoms. How do we do that? We multiply again, and we need to get the ratio. The ratio is, in one formula unit of NaClO4, it contains 4 oxygen atoms. So you put 4 oxygen, 4 O atoms. So that's the ratio of one compound of NaClO4. It contains 4 oxygen atoms. So we can get the accurate number of oxygen atoms in the compound itself. And if you look at our entire solution, the mole NaClO4 and the mole NaClO4 there will cancel out. The formula units NaClO4 will cancel out as well, and at the same time that one. So that what's left is just the oxygen atoms, which is the one being asked in the problem. So now we're going to do a multi-step inputting in the calculator. So what we're going to do is, we're going to input 4.67. So we're going to input 4.67 first. So 4.67 times, open parenthesis, the 6.02 times 10 to the 23. We close the parenthesis, and then we multiply again by 4. So times 4. Equal, you should get the whole thing here, but because there are 3 significant figures in the given, we're going to get the first 3 here. So the first 3 are 1.12. No need to round up because it's a 4 after the 2. So 1.12 times 10 to the power of 25. And the unit will be O atoms. O atoms in NaClO4. Okay?